Lesson 3.9, find horizontal or vertical tangent lines. A horizontal tangent line is just like what it sounds. It's going to be where the graph flattens out momentarily. So what you need to think of is reading this graph left to right. If I were to draw all these little tangent lines saying what's the slope at specific points, it would kind of follow along the curve like this. See how it's pretty steep, and now it starts to flatten, flatten, flatten. Well, here at this maximum, it would be completely horizontal. So that would be at -6. Well, then we would start going negative slope, gets steeper, steep, and then get more gradual, and then it would flatten out again here at -1. And then it would get more negative, more negative, more negative. Then we'd pick back up, we'd have all these little tangent lines, we'd start to flatten out here at 3, and then we'd get negative, more negative. Here at 6 is a problem. I call this, I didn't quite make my arrow in the right spot. I call this a corner or a cusp. Like in your teeth, they talk about a cusp. It's a corner or like a sharp point. Let's call it that too. We'll learn that actually that does not have a tangent line at all. Because when I come from the left, I'm negative, but when I come from the right, I'm positive. We have to have the slopes come to the same thing from the left and the right, just like we learned about in a limit. And then we can't use the endpoints either, because we're going from -9 to 9, but those are not included. So endpoints can't count, corner and cusp or sharp points can't count either. Then we talk about a vertical tangent line. That's where the graph becomes vertical momentarily. So again, can't use an endpoint. Think about tangent lines all along here following how the curves are going. Well, right here at -4 would be my first time it happens to be vertical. And what I think of is where it changes concavity. Concavity is how a graph is concave. It's either concave up, where it opens up like a smile, or it's concave down like a frown. So where that happens, where that changes concavity, there will be a vertical, not asymptote, but a vertical tangent line. And so we'd keep going. Here would be a horizontal one. Keep going. Here's that corner cusp. That's nothing. We get negative slope. We'd flatten out again. Here would be a horizontal. Keep going, keep going. And then right here at 6, it happens again, where we change from concave down to concave up. And so there would be those two vertical tangent lines. So let's try one. Your questions will only ask you about horizontal or vertical one at a time, but I wanted to go ahead and combine this and put both. So we're going to determine all the values of x where the function f has a vertical or horizontal tangent line on the interval -9 to 9. So see how it's not included? We cannot include our endpoints as a tangent line. So let's think about little lines going, going, going. Well, here's a minimum. That would flatten out at that bottom, which is at x is -7. So that would be our first horizontal. And then we'd go up, 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 up. This is a sharp corner, that's nothing. Down, 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 down. Flattens out again, here at -2. And then it starts going positive slope. Here at 1, it's changing concavity. It's going from concave up to concave down at 1. And then we keep going, keep going, keep going. It would flatten out again here at 4. Then it would keep going up and up and up and up and up. Okay, that gets steeper and steeper, but it's not vertical here or here. So we start back here, and we can't say that that's part of it because it's an endpoint, so those would be our horizontal and vertical tangents.